Lecture 17, tensor product denoted as this symbol over here, and the wedge product denoted this symbol. Okay? Now we call the wedge product, and this is tensor product. Now, a tensor is by definition a multilinear map, and the tensor product is the operation that builds a multilinear maps. For example, a 0-2 tensor like Tij is a bilinear form. It is constructed from the tensor product of the two one forms. You see, T is a tensor, is invariant, tensor is invariant, expressed. This Tij are the covariant, the components which belongs to the cotangent space, dxi, tensor product dxj. Similarly, a 2-0 tensor T, which is invariant, is Tij partial xi, tensor product partial xj. Or a mixed 1-1 tensor, this is Tij partial xi, tensor product dxj. Or a 0-3 tensor T, okay, which is Tijk dxi, tensor product dxj, tensor product dxk. You see, now let's present the contrast with the wedge product, because in the literature sometimes you get confused, okay, tensor product and wedge product. Now, the wedge product only appears when you are building alternate tensor, that is, differential forms, which are anisymmetric. You see, that's important here. For instance, dxi wedge dxj is a two-form alternating covariant tensor of rank 2. This here is minus dxj wedge dxi. This is, in contrast, dxi tensor product dxj is a general 0-2 tensor, okay, not necessarily anisymmetric. See, that's important, the difference here, okay, not necessarily anisymmetric. You see this notation, this denoted here. You see, that's very important. When you see the literature now, there is a distinction. So you can distinguish between the wedge product and the tensor product. That's okay.